Assalamu alaikum, brothers and sisters. Welcome to the journey of quest where we quench your thirst of knowledge. Why is uranium lead dating so essential in the world of geology? Well, imagine attempting to piece together the story of Earth's past without any timeline or chronological reference. It would be akin to trying to assemble a complex puzzle without the picture on the box. Uranium lead dating presents us with this vital tool, enabling us to understand geological time, track the Earth's age, and unravel the history of our planet. Uranium lead dating, often abbreviated as UPB dating, is a radiometric dating method that geologists use to date rocks and minerals. It is based on two isotopes of uranium, uranium-238 and uranium-235, and their decay to two isotopes of lead, lead-206 and lead-207 respectively. The process begins with the presence of uranium in a rock or mineral. This uranium isotope, whether uranium-238 or uranium-235, is unstable, meaning it tends to break down over time. This disintegration is a natural process that happens at a predictable rate, known as the half-life. For uranium-238, this half-life is an astonishing 4.5 billion years, while for uranium-235, it's slightly shorter at 700 million years. As these uranium isotopes decay, they each transform into a corresponding lead isotope. Uranium-238 decays into lead-206, and uranium-235 decays into lead-207. This transformation doesn't happen overnight, of course. It's a slow, steady process that occurs over billions of years. Now here's where things get interesting. By measuring the ratio of uranium to lead in a rock or mineral, we can calculate when the uranium was last heated or otherwise altered. Why is this significant? Because this information helps us determine when the rock formed or when it experienced a significant geological event. But how exactly do we measure these ratios? Well, first, a sample is taken from the rock or mineral. This sample is then crushed into a fine powder and dissolved in strong acids. Once the sample is fully dissolved, it's spun in a centrifuge to separate the uranium and lead. These elements are then measured using a mass spectrometer, a fantastic piece of technology that can accurately determine the amount of each isotope present in the sample. In order to appreciate the significance of uranium lead dating, let's dive deeper into the process. It's not as simple as picking up a rock and measuring its content. There's a meticulous procedure that every geologist follows. The first step is the collection of a rock or mineral sample from the field. A geologist must carefully choose a sample that's indicative of the geological event or time period they're interested in. This could be a rock from a specific layer of sediment, a mineral vein, or a piece of an igneous intrusion. The sample is then carefully extracted, taking care not to contaminate it with other minerals or materials. Next, it's crucial to document the sample's location and surrounding geological features. This includes noting the type of rock or mineral, its position within a geological formation, and any other significant observations. It's also important to mark the exact location using GPS, as this data can help provide additional context for the sample. In the end, the first part of the uranium lead dating process is all about careful collection and documentation. It's the foundation on which the rest of the process is built. Stay tuned as we delve into the next steps in our upcoming scene. Next, we bring the sample back to the lab. This is where the real heavy lifting begins. The rock or mineral sample, now documented and carefully preserved, is ready to undergo further processing. The first step in this phase is to crush the sample into a fine powder. It's a delicate process, requiring both precision and attention to detail. The crushing process is performed to increase the surface area of the sample, which makes the subsequent steps more effective. Once we have our powdered sample, we then subject it to a process called acid dissolution. This involves dissolving the powdered sample in a cocktail of strong acids. This step is crucial as it aids in the breakdown of the rock structure, allowing us to isolate the uranium and lead isotopes. It's akin to breaking down the walls of a fortress to get to the treasure inside. And with that, we reach the end of the second part of the uranium lead dating procedure. But remember, this is only the beginning. The real chemistry, the unraveling of the rock's age, begins now. So stick around as we continue our journey into the intricacies of uranium lead dating in the next scene. Welcome back to the third part of the uranium lead dating procedure. Having dissolved our rock sample in a cocktail of strong acids, we now have a solution that contains all the elements present in the rock, including our main players, uranium and lead. Our next task is to separate these isotopes from the rest. This is where our trusty centrifuge comes into play. By spinning the dissolved sample at high speeds, we can separate the isotopes based on their mass. The heavier lead isotopes are flung to the outside, while the lighter uranium isotopes stay closer to the center. It's a bit like a geological merry-go-round. Once we have our separated isotopes, it's time for the next crucial step: preparation for measurement. This involves further refining the isolated isotopes and converting them into a form that can be accurately measured. We need to be extremely precise here, as any mistakes could skew our results and lead to inaccurate dating. And there you have it, the third part of our uranium lead dating procedure. It's a delicate dance of chemistry and physics, and precision is key in this step. But remember, our journey is not over yet. Up next, we'll delve into the significance of this fascinating method. So stay tuned as we continue to unlock the secrets of Earth's geological history. Now that we have our separated isotopes of uranium and lead, it's time for the mass spectrometer to do its magic. This device will measure the quantities of our isotopes with extreme precision, allowing us to accurately quantify them. The mass spectrometer works by ionizing the isotopes and then accelerating them through a magnetic field. This field deflects the ions based on their mass, and by measuring the degree of this deflection, we can determine the quantity of each isotope present. After this, it's all about the numbers. We calculate the ratio of uranium to lead isotopes. These ratios are critical because they give us the information we need to date our rock or mineral sample. The higher the ratio of lead to uranium, the older the sample is likely to be. And there you have it, folks, the final step in our uranium lead dating procedure. This is where we get our dating data. It's a scientific symphony of isotopes, ratios, and mind-bogglingly old ages. It's a testament to human curiosity and ingenuity that we've developed a method to unlock the secrets of the Earth's geological past. Next, we will discuss the significance and the impact uranium lead dating has had on our understanding of Earth's history. So stick around, the story gets even more interesting from here. Welcome back, science enthusiasts. After understanding the detailed procedure of uranium lead dating, it's time to finally interpret the data we have obtained. This is where the real magic happens. The ratio of uranium to lead isotopes that we've calculated becomes our time machine. It unlocks the geological past of our rock or mineral sample. The age of the rock or mineral is calculated by using this ratio. The higher the ratio of lead to uranium, the older the sample is. This is due to the fact that uranium slowly decays into lead over billions of years. Therefore, a rock with a high lead to uranium ratio has had more time for the uranium to decay, indicating that it is older, but we don't stop there. Once we have the age of our sample, we use this information to understand the geological history of the area where the sample was collected. This can include identifying periods of volcanic activity, tracking the movement of tectonic plates, or even uncovering evidence of past climate changes. In essence, these rocks and minerals serve as nature's time capsules, each one holding a unique piece of Earth's fascinating past. And that's how we travel back in time with uranium-lead dating. By combining advanced scientific techniques with our natural curiosity, we can uncover the mysteries of our planet's ancient history. Stay tuned, as next we will delve into the significance and the impact uranium-lead dating has had on our understanding of Earth's history. In summary, uranium-lead dating is a fundamental tool in the field of geology, providing a timeline that helps us understand the Earth's past. The process involves the decay of uranium isotopes into lead isotopes over billions of years. By measuring the ratio of uranium to lead in a rock or mineral, we can determine when the rock was last altered or formed. This method of dating is a powerful way to peek into the Earth's history, revealing secrets that would otherwise remain hidden beneath the surface. Remember, every rock has a story to tell, and with uranium lead dating, we have the ability to listen and understand these fascinating tales of geological time. So next time you hold a rock in your hand, remember the intricate processes it has undergone and the immense timeline it represents. It's not just a rock, it's a piece of Earth's history. Thanks for watching us share our videos, subscribe our YouTube channel, and press the bell icon and stay curious for new uploads.